Welcome to today's deep dive. We've got it's a classic infrastructure nightmare for you today. You have a high-res video source and a screen,
Yeah.
but they are separated by, say, 1,600 feet of airport terminal or stadium seating.
Yeah, that is a seriously long run.
Right, and if you try to bridge that gap with just a standard copper DVI cable, you're going to get a fuzzy picture.
No, digital signals don't do fuzzy. You hit the digital cliff, you'll get sparkles, artifacts, or mostly just a terrifyingly black screen.
Because the physics of copper just can't push electrons that far without a booster.
Exactly. Which brings us to the hardware on the table, the Kramer 610T Detachable DVI Optical Transmitter.
Right, and the mission of this deep dive is unpacking how this specific device bridges that distance gap by swapping electricity for light.
It's a compact unit, part of the Kramer Tools family, but the engineering inside is surprisingly robust. It converts that DVI electrical signal into an optical one to send it up to 500 meters.
But looking at the sources, what really stood out to me is that it doesn't just shove everything into one fiber strand.
No, that is the key differentiator here. It uses multi-mode fiber.
So it actually uses 4 separate LC optical connectors.
Right. Instead of multiplexing everything and risking latency or compression, it builds a 4-lane highway. You have red, green, and blue data, each on their own physical strand.
And the 4th strand is dedicated entirely to the clock signal.
By physically isolating that timing mechanism from the color data, you eliminate a lot of the synchronization errors that usually plague long-distance transmission.
It's a very brute force approach to signal purity.
It really is. And because of that separation, the resolution holds up perfectly. We're talking WUXGA.
So 1920 by 1200 at 60 hertz.
Which is still the gold standard for a lot of professional data displays and signage. It's pushing a maximum data rate of 4.95 gigabits per second.
That's 1.65 gigabits per graphic channel. But there's another problem with a 500-meter run that isn't just about the picture quality.
With a handshake.
Right. Usually your computer talks to the monitor to ask what resolution it can handle.
And if that monitor is a quarter mile away, that conversation simply can't happen. The source assumes nothing is plugged in and shuts down the port.
So the 610T has this EDID capture feature. You plug the transmitter into the display first, and it literally memorizes the monitor's identity.
It clones the EDA, the extended display identification data. So when you walk back 500 meters and plug it into the source, it tricks the computer.
It basically says, "Hi, I'm the monitor, and I'm right here."
It effectively ghosts the monitor so the source feels safe sending the video feed. That is a massive time saver for installers.
Because you really don't want to troubleshoot a blank output.
Exactly. Speaking of installation, the power handling is smart too. It comes with a power adapter, but if your DVI source is compliant and pushes 5V DC, the 610T can actually run without external power.
Always nice to avoid hunting for another outlet. Now, we do have to address the limitation because this isn't for everyone.
Right.
If you are trying to beam the latest Marvel movie to a projector across a campus, you are going to hit a wall.
A very hard wall. This device is not HDCP compliant.
So it strips out the handshake for copy protection.
It just doesn't support it at all. HDCP is required for Blu-rays, Netflix, and most commercial entertainment. If the content is encrypted, the 610T will just give you darkness.
Which positions this squarely in the professional realm. Control rooms, flight schedule boards, industrial monitoring.
Places where you own the content. It connects to the Kramer 610R receiver on the other end or directly into a digital matrix system.
It's infrastructure for data, not a home theater extender.
Precisely.
And if you are in the procurement stage for a build like that, this unit is available via HDTVSUPPLY under their Wolfpack line. And they offer a 10% discount code.
Definitely worth noting for the bill of materials.
So to wrap up, we have a device that uses 4 strands of glass to keep color and time perfectly synchronized over 1/3 of a mile.
It really solves the distance problem without the compression artifacts you get from other extenders.
It does make you wonder, though. In a world completely obsessed with 4K and 8K specs, where do robust, long-range WUXGA solutions like this still hold the most value?
It raises a valid point about stability versus pixel count. When the data absolutely has to get there, sometimes the proven industrial standard beats the bleeding edge.
Something to mull over next time you trust a departure screen. Thanks for joining us on this deep dive.